Continuing with inverse trig functions, and this is the second part of the inverse trig functions lesson. This one is looking at the scary phrase, but the composition of trig and inverse trig functions. And all that means is you're putting one inside the other, like little Russian dolls. Hope I didn't offend any Russians watching this. All right, so here's an example. We did a few of these in class. The inverse cosine of the cosine of 7 pi over 6. And for problems like this, all we're going to do is start off by looking inside. So I'm looking inside at this part right here. The cosine of 7 pi over 6, which means we find 7 pi over 6 on my unit circle. It's right here. And the cosine means we need to find the x-coordinate. Whoa, what's going on here? We need the x-coordinate of 7 pi over 6, which is negative root 3 over 2. So answering just the inside part, I know the cosine of 7 pi over 6 is negative root 3 over 2, and I cleaned that part up. Now we look at the rest of the problem, and I need the inverse cosine of negative root 3 over 2. Now what you need to remember is the inverse cosine, you only look at the top half of the circle. So here I am looking right only at these angles from 0 to 180. And cosine is the x-coordinate. My x-coordinate is negative root 3 over 2 right here, which is an angle of 5 pi over 6. So the final answer is, I forgot my 5. Let's just start writing that over again. 5 pi over 6. And there's our answer to this problem. The whole thing cleans up to 5 pi over 6. Start on the inside, work your way out. Okay, let's try this one. The sine of the inverse sine of 1/2. Well, inverse sine is, inverse sine means, this one's kind of backwards. The sine is on the outside, inverse sine is on the inside. So I'm only looking at the inverse sine part. So let's see, inverse sine. I'm only looking at that part of it. So the inverse sine of 1/2 means I need to find on my circle where my y-coordinate is 1/2. But remember, for inverse sine, you only look at the right side of the circle. So here, I'm looking over here, and inverse sine of 1/2, my y-coordinate is 1/2 right here. So the inverse sine of 1/2 is pi over 6. And now I'm asking you, what is the sine? I got to do this sine on the outside, the sine of pi over 6. And this is going to be kind of silly. We look back at that same angle, and you give me the y-coordinate, which is 1/2, which is our final answer. So we kind of went in a circle there. The inverse sine of the sine of 1/2 ends up being just 1/2. Let's try this one. The tangent of the arc cosine of 3/5. Now remember, arc cosine and inverse cosine are the exact same thing. They are interchangeable. And if we follow the same procedure that I just went through for those last couple of problems, let me see. I kind of like this box one. So let's make it jump out at you. Y'all ready? Got your 3D glasses on? Okay, so the arc cosine of 3/5 means find the place on the circle where my x-coordinate is 3/5. And we're about to run into a huge problem because there is no such place on our unit circle that we're aware of. It's not a nice angle that's on the unit circle. So we actually have to solve this a different way. And the unit circle does us no good. So I'm going to take the unit circle, I'm going to shrink it up into insignificance, and we're just going to make it disappear, and we're going to, wait, whoa, where'd it go? Oh, that was scary. All right, so the unit circle is of no use on this problem. So that means we have to think of this problem in a different way, and I'm thinking inverse cosine. I'm going to do the inverse cosine, the arc cosine. If you remember, one of the notes I gave you way back in the day, I said inverse cosine of something is the exact same thing as saying cosine of some angle is equal to x. So inverse cosine of x equals theta is the exact same thing as cosine theta equaling x. So what I'm going to do, I'm going to use that idea. I'm going to say that this whole thing is some angle theta. Whenever you do the inverse sine, inverse cosine, arc tangent, any of those arc things, inverse things, you're going to get an angle answer. So I know that arc cosine of 3/5 is going to give me some answer of theta. And I'm going to twist this around. This is the exact same thing as saying cosine of the angle is equal to 3/5. So I've reworded the problem. Instead of the arc cosine of 3/5, I'm saying cosine theta equals 3/5. And now we go back and think about our old friend Sohcahtoa. You remember we talked about Sohcahtoa. Native American helped Lewis and Clark out with their math studies as they explored the Great West. So Sohcahtoa, you think about her, and I know that cosine tells us adjacent over hypotenuse. So what I'm going to do here is I'm looking at 3/5. I know that that represents the adjacent side and the hypotenuse of a right triangle, and I'm going to draw a triangle that fits this situation. What we do need to remember is that for arc cosine, you always consider just the top half of the circle. And if cosine is positive, which it is, cosine is positive 3/5, that means we're only going to look at the first quadrant. So that's where I draw my triangle. I'm going to draw a triangle going into the first quadrant. That was really bad. So I'll come down. I'll tell you what, I'll use a straight line tool. So I'm going to draw the first quadrant. Now when you draw your triangle, you always draw from the origin going into the quadrant, then back to the x-axis. You always draw it that way. Inverse cosine, we always look at the top half of the circle, and this time it's going to be the first quadrant because cosine is positive 3/5. And then I label my triangle. This is my theta, and we know that the adjacent side is 3, and the hypotenuse is 5. And then I can channel my Pythagorean theorem skills to solve for my missing side length right here. So 3 squared plus that missing side length is equal to 5 squared, and you will get x2 equal 4. So this side length right here is going to be 4, and I solve that simply with Pythagorean theorem. And now I have this triangle, and I go back to my big function. My original question said find the tangent of all of this. So what I need to do now is find tangent of this angle theta. So now tangent of theta, which is what we're asking for, tangent of theta, tangent of all that. Tangent is simply opposite over hypotenuse, which is 4/3, and that is your answer. The tangent of the triangle the arc cosine tells you to draw. Really confusing the first time, probably going to be confusing after the second time, and hopefully we'll start getting the hang of this after the third time. So you start, if it's not on the unit circle, you start by drawing a triangle that fits that situation. Let's try this one. Cosine of the inverse tangent of 2/3. Well, negative 2/3 is not on the unit circle anywhere. You're not going to be able to get it anywhere. So this is another problem. It's inverse tangent. So I've got to think, okay, inverse tangent, we're limited to looking at the right side of the circle. And let's see, this right here is the exact same thing as saying tangent of some angle theta is negative 2/3. Tangent is negative. Tangent is negative. Well, if tangent is negative, and you get tangent by dividing your sine and cosine, the only way you're going to get a negative answer in the right side of the circle is if you were in the fourth quadrant. Because in the fourth quadrant, x coordinates are positive and y coordinates are negative. If you divide those, you will get a negative answer. In the first quadrant, both coordinates are positive, which will not give me a negative when you divide. So I know I'm looking in the fourth quadrant, and that's where I draw my triangle. So let me draw the fourth quadrant so I can get my triangle done. So I'm going to draw a triangle going into the fourth quadrant. And when you draw your triangle, remember, you always start at the origin, and you go out into the quadrant, then back to the x-axis. So here's my right triangle, and then, whoa, there's my right triangle, and then we need to think about our friend Sohcahtoa tangent. Let's see, Sohcahtoa. Tangent is opposite over adjacent. So I'm looking at this. This means my opposite is 2, and my adjacent is 3. And the angle is always this small angle right here back to the x-axis. Opposite is 2, and adjacent is 3. Except one of them has to be negative because 2 over 3 needs to be a negative answer. The one that's going to be negative, we went right and we went down. Down is the negative measure. So I go right and down. So my down is my negative 2. Then I'll do Pythagorean theorem to solve for my hypotenuse. So 3 squared plus negative 2 squared is equal to my hypotenuse squared. 3 squared is 9. 2 squared is 4. 9 plus 4 is 13. And I get a hypotenuse of square root 13. So I take out the h and I put in square root 13. And then I go back to my question. We need to find the cosine of this angle, the cosine of all of that. And the cosine of the angle, cosine is adjacent over hypotenuse. So my cosine is adjacent, 3 over hypotenuse, root 13. There's our answer. Draw a box around it and be happy. So if you draw a triangle to fit the situation, if it's not on the unit circle, and then you answer from the triangle. Yeah? Questions, comments, concerns, thoughts on life? All right, one more problem. The cosecant of the inverse secant of negative 3. Well, we're going to have to do the same thing because negative 3 is not anywhere on the unit circle. So I'm going to look at this part right here, the inverse secant. And we have to think inverse secant is only on the top half of my unit circle. That's our restriction for inverse secant. And I know that secant, let's see, if that represents some angle, that means that secant of the angle has to equal negative 3. I'm not a big fan of thinking in terms of secant. If secant is negative 3, that's the exact same thing. Since secant and cosine are reciprocals, that's the same thing as saying cosine is negative 1/3, the reciprocal of negative 3. So I'm going to draw a triangle that fits this situation. Cosine, think about Sohcahtoa. Cosine is adjacent over hypotenuse. And cosine is negative. Secant and cosine are negative on the top half of the circle. That means we have to be looking at the second quadrant because my x-coordinates are negative in the second quadrant. So I'm going to draw my triangle going into the second quadrant. So let's draw my second quadrant. X-axis, y-axis. You draw your triangle going into the quadrant and then back to the x-axis. That's a right angle. Here's my angle theta. And then cosine adjacent over hypotenuse is 1 over 3. So we have 1 and 3. And one of them has to be negative because it's negative 1/3. So if I travel left, that's a negative distance. Your hypotenuse will never be negative in these triangles. Your legs can be. You could have a negative leg here, negative leg. If you go down, the hypotenuse will always be positive. We do need to use Pythagorean theorem to solve for the opposite sides. So negative 1 squared plus 3 squared, negative 1 squared plus x squared equals 3 squared. 1 plus x squared is 9. Subtract 1, you get 8. Take the square root, you get the square root of 8, which cleans up 2. 2 times the square root of 2. So x is, your opposite side is 2 square root of 2. And I'm always thinking whether this is positive or negative. If you go left and up is a positive direction. If I went left and down, then I would need to do a negative 2 root 2. But since I'm going up, this distance is positive. Then I go back to my original problem. And we need to find the cosecant of this angle. So the cosecant of the angle is, let's see, cosecant and sine are reciprocals. So if I could find the sine of the angle, sine is opposite over hypotenuse. So sine is 2 root 2 over 3. If I know what sine is, then I can simply flip it to get the cosecant. So now that I know what sine is, I know that cosecant, I'll write it over here where I have more room. Now I know that cosecant, therefore, cosecant of the angle is, you simply flip it, 3 over 2 root 2. And I am okay if you do not rationalize the denominator. I know some math teachers would cringe at that. Math League of America is probably plotting my demise right now. But there's really no point in rationalizing for problems like this. So there we go. If your situation is not on the unit circle, then we're going to go the triangle route to solve the problem.